There isn't a standard table used to identify the rainfall intensity for the Phi index. Check this next example here in hydrology. For a certain water basin, if precipitation occurs, there are water losses and possible runoff if the rain is ample enough. In order to compute for the runoff, we need to make the infiltration constant. This is done in three methods. The first is the Phi index, with the concept that the rainfall volume is equal to the runoff volume. The second is the F average method, taking the average infiltration loss throughout the storm duration. The third is W index, which takes the infiltration rate during the time the intensity is more than the infiltration capacity rate. Let's delve into the Phi index deeper. This index computes for the infiltration rate from the rainfall excess, which is taken as equal to the runoff volume. This method uses the hyetograph of the excess rainfall. So to place the description into a mathematical sentence, we can say that Phi index is the ratio of all losses due to infiltration and the duration of the rainfall. From the graph, we take the Phi index as the pink area over the duration of the rainfall. Now to correlate the Phi index with the runoff. The rainfall volume less the Phi index by the duration of the excess rainfall is equal to the total direct runoff. This is written as P minus Phi times T is equal to R. By transposing R and Phi times T to the opposite sides, then divide the expression by the time, we take the Phi index as the difference of the precipitation and runoff all over the duration, or that is P minus R over T. And since there are different entries at various times, we can write the runoff as the summation of P minus Phi times the duration. The procedure of looking for the Phi index is by trial and error, which means expect a number of iterations until the final value is verified to be correct. The first step is to count the number of pulses. This is just the number of entries in the record. Next is to look for the value of Phi, using the function we discussed earlier. Check the number of entries giving excess rainfall. If there is a discrepancy between the impulses, repeat the procedure. The next example includes a record of a storm over a catchment area taken at different time intervals. The total direct runoff is also recorded as 23 millimeters, and we are to compute for the Phi index. Take the number of entries as the pulse number. The Phi index goes with the hyetograph, which requires time and intensity. Intensity is taken as the incremental depth over the incremental time, so we solve for the incremental time first. The first entry is 0.5, followed by the difference of 1.3 and 0.5, which is 0.8. Then 2 less 1.3 is 0.7. 3.5 minus 2 is 1.5. And another 1.5 from 5 less 3.5. After time, we also take the incremental rainfall depth as the rainfall provided is cumulative. So the first entry is taken as it is, 5 millimeters. Then take the differences of the consecutive entries, starting with 18 minus 5, which is 13. 30 minus 18 is 12. There is also 38 less 30, giving 8. and 42 minus 38 is 4. Having both the incremental depth and time, we can compute for the rainfall intensity, which is just their ratio. So 5 divided by 0.5 is 10. Then 13 over 0.8 is 16.25. Next is 12 upon 0.7, giving 17.14. Followed by 8 divided by 1.5, resulting to 5.33. The last is 4 over 1.5, which is 2.67. We can then draw the hyetograph after learning the intensities. We work a little further by taking the areas of each bar plotted in the hyetograph. This area is the precipitation volume. The first is 0.5 by 10, which gives 5 millimeters. Next is 0.8 times 16.25, and that is 13. The third is 0.7 with 17.14 resulting to 12, followed by 1.5 times 5.33, which is 8. The last entry is from 1.5 times 2.67. That gives 4. We can then compute for P easily having this precipitation column. Let's continue with the first phi index trial. This includes all the entries. There are 5 of them, taking the time duration of 5 hours. From the function, take the summation of the precipitation of the pulses, where P is computed as 42 millimeters. Place this into the formula and get 42 less 5 phi is equal to 23. Transpose terms and compute for phi as 42 minus 23 divided by 5 to get 3.8 millimeters per hour. This index is a little more than 1 bar, which takes no runoff on the 5th pulse, violating the phi indices concept. Let's try another trial where we take out pulse 5 from the list, giving M of 4, and the duration is now just 3.5 hours. With the equation, solve for P from the table. That is 5 plus 13, 12, and 8, resulting to 38 millimeters. So the function becomes 38 minus 3.5 phi as equal to 23. And by rearranging terms, we have phi as 38 less 23 divided by 3.5. And it yields 4.29 millimeters per hour. With a constant index of 4.9, all the 4 pulses have rainfall excess, which can be converted into runoff. Thus, the phi index is 4.29 millimeters per hour.